Hi everyone, welcome to our YouTube channel. Today we will talking about flow measurement. Flow is defined as a fluid liquid gas in motion. There is importance of flow measurement is to ensure the process is at the design operating condition and to control the quality of a product. There are also 3 different flow quantities to be measured. It is the actual velocity at a given point measured in meter per second, the volumetric flow rate measured in m3 mean, and the mass flow rate measured in kilogram per second. Firstly, we will use some formula to calculate the flow. It divides into 2 terms, it is mass and volume flow rate. Firstly, we will learn about measurement of flow in terms of volume. Volumetric flow rate is to measure the volume of fluid passing through a given cross-section area per time. The formula to calculate volumetric flow rate of the liquid can be written as the above. Next, we will learn about measurement of flow in terms of mass. Mass flow rate refers to the mass of a fluid passing through a specific cross-sectional area per unit time. Diagram above have been attached with formula. Mass and volume have their own SI unit. Above there are some example SI units for mass and volume. There are 5 types of flow meter. The application of turbine flow meter is volumetric flow, mainly used for liquid, used for gas as well. Next is Coriolis flow meter. Mass flow, mainly used for liquid, used for gas as well. Therefore, ultrasonic and orifice flow meter have same function. It is volumetric flow, mainly used for gas, used for liquid as well. Lastly, we have positive displacement flow meter. The application of this flow meter is volumetric flow, used only for liquid. Factor affecting flow rate in pipeline. Poiseuille's law shows this depend on 3 factors. It is the radius of the pipe, the length of the pipe, and the viscosity of the fluid. Next, we will learn about nature of the flow. 3 basic laws govern the nature of fluid flow. Is the continuity equation, the Bernoulli equation, the conservation of mass. First is the continuity equation. This law covers the volume flow rate passing a given point in a pipe. The volume flow QV flowing through a pipe cross-section A in a unit of time is always constant if density is constant. As the cross-section becomes smaller, the velocity must increase to maintain the same volume flow rate. Second is the Bernoulli equation. The Bernoulli principle states that as the speed of a moving fluid increases liquid or gas, the pressure within the fluid decreases. Lastly is the conservation of mass. Mass can neither be created nor destroyed. The total mass flow rate at any given point in a pipe will be constant. This law has a particular significance for gas flows. And now we will learn about Reynold number. Reynold's number is a dimensionless quantity. It is used to determine if flow is laminar, transient, or turbulent. The diagram shows a formula for a Reynold number. Flow regimes have been divided into 2 sections. It is laminar flow and turbulent flow. Laminar flow move in well-ordered adjacent sliding layers, meanwhile turbulent flow move in all directions. Lastly, key factor, the number of pulses expected for every one volumetric unit of fluid passing through a given flow meter, and is usually encountered when dealing with pulse signals. Is the K-factor uniform for different flow meters? Different flow meters have different K-factors due to their unique design, operating principles, and construction. In a turbine flow meter, the K-factor is determined by the rotor design, the number of blades, and the geometry of the flow passages. In a magnetic flow meter, the K-factor is influenced by the pipe size, the magnetic field strength, and the flow profile. Flow measuring devices. There are so many flow measuring devices in the industry, such as differential pressure flow meter, variable area flow meter, vortex flow meter, magnetic flow meter, Coriolis meter, positive displacement meter, ultrasonic flow meter, and turbine flow meter.